demo tenant. It is your email at this very painful domain of m365x178.300.onmicrosoft.com. So your email alias, so my email address is christopher.lee@improven.com. So my username for my demo tenant would be christopher.lee@domain.com. And then the password is listed there. And as I said, I put it in the chat window. So if you want to grab that versus having to manually write down that password, it'll be available in the chat throughout the remainder of the meeting. So with that, let me go ahead and jump into the content of why we're here. We want to talk about closing the attack surface or reducing the attack surface of cloud services. So first, what is the attack surface? And if we look at public cloud, one of the benefits that everyone had one of the big selling points to go into public cloud was available anywhere, anytime, any device, any user. And that sounds great when you're trying to plan for business continuity and high availability and just overall productivity of your employees. But from a security perspective, that doesn't sound too great. And mostly because if it's available and accessible everywhere, that means it's not just accessible to your employees, it's accessible to potential bad actors as well. So if we look at this attack surface, what is an attack surface? It's pretty much any entry point somebody has into your environment. So what we want to talk about today, and I'll go over some practical suggestions and capabilities in the cloud, is reducing the attack surface. And we often refer to that as closing the door. You think about it this way: you're closing the front door of your house, but you're giving your friends and family keys, right? So that way you're allowing the people you trust to come in, the people you want to come into your house. But the neighbor 3 doors down can't just walk over to your house and walk in the front door because they don't have a key. And that's really what we mean by closing the front door. And the attack surface is really made up of 2 vectors. There's the people and there's devices. The people part of it, unfortunately, people are always going to be the weakest link, and not just from a Microsoft cloud, but any technology solution. People are always going to be the weakest link, and it's because people are human. They make errors, and they're not necessarily intentionally being malicious or bad, but errors happen. People can get tricked. They're much more easy to circumvent with social engineering and phishing scams and things like that. So people are always going to be that weakest link. But people aren't accessing the services just by being human. I can't sit in my desk chair and just magically access the cloud. I have to have some interface, and that's our devices. So that's our second vector for attack surface, is all the devices. And especially with work from home and the growing amount of BYOD out there, it's becoming very difficult to manage and understand what kind of devices are accessing the environment. How do we control those devices? How do we put some security around it? So hopefully, as I walk through the remainder of this presentation, we'll see how we can address both of those attack vectors in the real world scenario. So the first item that we want to consider is multi-factor, and you've probably heard us say this 100 times before. You need to use multi-factor authentication. It is the best thing you can do to protect your environment, because if we look at attacks against cloud services, 80% of all attacks are credential-based attacks, and MFA can block over 99% of those credential-based attacks. So that alone says you can block the majority of these attacks, the vulnerabilities to your cloud environment, by requiring MFA. And it's not just for your admins. That's kind of our general practice. That, hey, if you're an administrator, you have to provide MFA, but our general employees, our user population, we don't necessarily require it all the time for them. I'm going to challenge you and say that, yeah, you should be requiring MFA at all times for all of your employees, because of the benefit this has alone. Over 99% of all attacks can be blocked. Credential-based attacks can be blocked by MFA. And the other part is The component for Microsoft Authenticator. Love it or hate it, the reality is the Microsoft Authenticator app is going to become a much more important aspect to your cloud security with Microsoft Cloud Services. Right now we're used to using the Authenticator app for push notifications for MFA, but there's going to be major advancements coming out over the next couple months with the Authenticator app. If you keep on top of where Microsoft is heading, we're definitely going to be looking and hearing more about passwordless authentication. And the Authenticator app is going to be a big component to passwordless authentication. So definitely multi-factor, you should be using it, and that shouldn't be any news to any of you. But I'm just going to reiterate that out there that please, please, please push multi-factor authentication across your entire organization. The second concept is conditional access. Now, if multi-factor authentication is going to protect our users, conditional access is the first thing to protect that front door, so to speak. It is our front door, essentially. And this is a ugly slide, and I say that every time I have to present this slide, but it is a good slide to present what conditional access is. So everyone should be using it. So I'm not going to dive deep into all the details of conditional access because you know what it is. But it's our first door, so to speak, to shut or start closing to preventing users or bad actors from getting into our environment. And that's combining a lot of different signals, not just identity, but we're looking at the devices, we're looking at location, we're looking at what client app you're using, what service you're trying to get to, and then we can layer all the Microsoft intelligence on top of it to determine risk and things like that. So I'm going to dive into conditional access a little bit deeper from a demo perspective here in a few minutes. So I don't think I really need to cover it on what it is too much here. But one point I do want to make with conditional access, it leads into blocking legacy authentication. Legacy authentication is, we're slowly getting away from it. Microsoft is slowly saying, hey, we're no longer supporting it for Exchange Online and things like that. But it doesn't mean that legacy authentication is still not out there. Legacy authentication was big when we had Office 2010, but it's no longer supported. So we really should be leveraging modern clients today that don't have to rely on legacy authentication. And the reason legacy authentication is bad is because we can't apply the additional security controls that we have available to us in conditional access to legacy authentication. It just doesn't know how to process a multi-factor authentication challenge. It doesn't know how to report device health, things like that. So it really is a weak point when it comes to your overall cloud security posture. Where we do see a lot of legacy authentication is when you have third-party apps, third-party integrated services to your environment. So like something like a third-party cloud backup solution that ties into Office 365 that's doing a cloud-to-cloud backup, or even a scripted process that you may have that runs some maintenance on Exchange. It maybe sets some attributes or queries some mailboxes in the cloud that you run as a scheduled task. Those typically have to be run using legacy authentication because modern is typically a interactive authentication prompt. It's not something that you typically just pass credentials or store credentials somewhere and allow in. So how do we address your needs of having to run scripted processes and get away from legacy authentication? And I'm actually going to walk through how we can do that using Azure and some integrations with Azure Active Directory. So with that, I'm actually going to jump into a demo here because I really wanted to focus more on hands-on demos versus just watching slides the whole time. So you do have access to the demo content or the demo environment, so go ahead and log in if you want to. But the first thing I want to talk about in the demo environment is you might hear, Azure security defaults being thrown around out there, the terminology, Azure security defaults. And they're probably not going to be a big component for you right now because most of you are using conditional access. And you can't use Azure Security Defaults and Conditional Access at the same time, but I think it makes sense to understand what they are. So when you hear that term thrown around, you're familiar with it. But Azure Security Defaults, you would think, if I go to Azure Active Directory here, you would think that that would be a setting underneath security. Unfortunately, it's not that simple. If I look under security, I don't really have anything here labeled for Azure Security Defaults. Instead, Microsoft decided to put that under properties of your Azure AD tenant. So when you go to properties, you have this little link here, not very flashy, not very visible either. It's just a small link, but when you click it, you either can turn it on or turn it off. And as I said, if you have conditional access in place, you can't use Azure Security Defaults. They're mutually exclusive. We use either one or the other. But Azure Security Defaults implements some very good controls that we would recommend that you implement with conditional access. And that's really requiring all users to register for multi-factor authentication. It's requiring all admins or privileged accounts to perform multi-factor authentication for all authentication attempts. It's blocking legacy authentication. And then it also requires MFA for when certain privileged activities are taken, such as connecting Azure to the Azure portal or using PowerShell to connect to Azure remotely to run commands against. It would require multi-factor authentication for that. So very good controls available with the Azure security defaults. The downside to it is the inflexibility. You don't have any customization. This is the only setting we have for Azure security defaults. We can't tweak and exclude anybody. It's on or off across the entire tenant. So that's where we want to look at using conditional access, and that's where we can get more granular. But before we jump into the conditional access, one of the things I want to show, and we all should be doing, is blocking legacy authentication using conditional access. But it's often a question: how do I identify if condition or legacy authentication is being used in my tenant? And it's not necessarily the foolproof way, but it's an easy way to get a quick view of whether legacy authentication is being used. And it's using the sign-in logs within Azure AD. So if I click in my sign-ins here, I'm going to go ahead and give it the last month. So I have the most data available for me here. But you don't have your filters available. You have to add the filter. And what we're looking at is client app. So if I click client app, hit apply, it doesn't do anything. It just makes the filter available to me. So I have to go set the filter. And Microsoft has now categorized all of these different client apps as either modern auth or legacy clients. So if I go ahead and just check all of these boxes for legacy authentication clients and click outside the box, it's going to update my filter. And you can see here, yeah, I've got some legacy authentication being used in my tenant. Now, this all correlates back to when I first spun up my demo tenant, which is interesting. Microsoft is actually doing all this stuff via some script out there using legacy auth. But this tells me, hey, legacy authentication is being used. So now I know, hey, go look at Exchange Online. What's being done? Well, it's web services that's being consumed for legacy authentication. So I need to go find that process and maybe investigate how I can move away from legacy authentication for whatever I'm doing with Exchange Web Services here. But this gives you a good quick snapshot of, hey, is legacy being used? So that if you implement a conditional access policy to block legacy auth, you're not just going to break stuff unintentionally for your business. So now that we know if legacy is being used, we want to block it. And that's going to be done through conditional access, but there's really two ways for us to block via conditional access, and that is really an indirect or a direct block. Now, it might be a little confusing, but an indirect block and a direct block pretty much differ in whether you're using a grant control or a block control. So let me try to explain this, because this actually applies to the concept of conditional access in general. And how it's scoped, because a lot of people misunderstand conditional access to be like a firewall, and it's not. Again, looking at public cloud, everything's open by default, right? So we need to close things down explicitly, and that's where we start getting into an indirect scenario. But first, let me show you direct and what I mean by that. So if I wanted to create a direct block policy, what I need to do is scope this to all users, all cloud apps, And I am, going to go to conditions. And what I want to focus on, just like our sign-in logs, is look at the client app and configure it for legacy authentication clients. So this is pretty much going to say, hey, for all users to access to all services, if they're using a legacy authentication client of some sort, apply this policy. And what I'm going to do is block it. So if I enable this policy here, I'm going to just immediately directly block the use of legacy authentication. So that's one way, and that's kind of a forceful way to block legacy authentication. But that will apply across the board. And if you had to exclude some service accounts, you could do that for your scripted processes or your third-party SaaS integrations. You can do that. But hopefully, third-party SaaS apps that are integrated with Azure AD will eventually move to modern authentication. And I'll show you a workaround for getting away from legacy authentication for some scripted processes here in a minute. But I'm going to go ahead and say, you know what, just to make sure I don't lock myself out, I'm just going to say apply this to all guest users and external users, but you get the idea. I could apply this to all users. Now, an indirect block follows not a block, but it's a grant control. So I'm going to title this indirect legacy block. And what I want to do is create conditions or controls, apply controls that legacy authentication can't satisfy. So if I want to, let's say I'm going to apply this to all guest users, I would apply it to all users, but just to make sure I don't lock myself out unintentionally during my demo, I'll say all guest users. I'm going to apply it to all cloud apps. And my condition here, I'm not going to look at what the client app is. I don't care about this at this point. But what I want to do is say, you know what, I'm going to grant access, but I'm going to require multi-factor authentication, or I'm going to require Intune compliance or domain join via a hybrid Azure AD join. By doing this, I'm indirectly blocking legacy authentication, because when someone tries to log in to any cloud service, the control that they're going to be presented is a control that legacy authentication can't satisfy. When I get that authentication prompt, that multi-factor authentication prompt from Azure, when I try to use Outlook 2010, I'm just going to get an authentication prompt loop. They'll ask me for my credentials. I'll type them in. Azure is going to respond back to Outlook 2010 saying, hey, you need to challenge or complete an MFA challenge. Outlook 2010 doesn't know what that means, and it's just going to say, hey, give me your credentials again. And you'll just get stuck in this loop of trying to enter your credentials, but you're never going to be authenticated into the service because you can't satisfy the multi-factor authentication. So indirectly, we're blocking legacy authentication. Now, the risk you run to using an indirect block is that you may have a scenario that you're not accounting for. Most likely, you're not going to scope this policy to all users and all cloud apps. You're probably going to scope a policy that requires controls to certain services like Exchange and SharePoint or Teams. But that leaves the gap of maybe there's a service that's not included there. So I do have a blog post on dependent services within conditional access, and I'll use the example for Intune device enrollment. If I look at my cloud apps here and I wanted to select a specific app, if I type Intune in here, you see I have some apps here named Intune, but if I was doing a block rule and I excluded both of these, I still would not be able to enroll my device with Intune, because these two selections don't include all of the dependent services underneath the hood within Azure and Microsoft Office 365 that are necessary for me to enroll a device. So just by selecting this doesn't necessarily mean I'm selecting everything related to device enrollment. So that's the risk that you run when you don't select all cloud apps. And most likely, you're not going to apply a policy that applies to all cloud apps and conditions or grant controls here that are this strict for everything at all time. Now you might, and that would be great if you can get to that level of security, but most likely you're not going to. That does present the potential that you might miss a specific use case, and then now legacy authentication can be exploited in that use case because we're not directly blocking. So hopefully that explains a little bit better of an indirect and direct block, and how you can prevent legacy authentication from being used. But you will have the challenges with third-party SaaS apps. Not everyone can integrate using modern auth, so that's something we're just going to have to deal with, and that's where we can leverage the exclusions here on the scoping. So if you have a service account that's being used, you can go ahead and exclude it here as well. Any questions? I'll just pause real briefly. Any questions at this time on what I've covered so far? All right. So the other item that I'm going to go in here on the demo is what happens if you have a scripted process, right? We have a scheduled task that calls a PowerShell script that uses a credential variable that's stored on that server. And there's a way to do a secure credential stored on a server that your script can call. But again, that's leveraging legacy authentication to the cloud. So your credentials may be secured on the server or on the system that's being used to run a scheduled task. But ultimately, you're poking a hole in your cloud security posture to support legacy authentication for that to happen. How can we get away from that? And the answer is using security principles. Now, there is a capability called Azure Automate. I don't have an Azure subscription set up to my demo tenant here, but if you did, you could set up an Azure Automate playbook, which is really your script stored in Azure, your PowerShell script stored in Azure, and it creates a service principal that it performs the authentication to your tenant against. Now, a service principal is very much like a user account, but it's not a named user. It is an object that lives in the cloud that is used to access cloud resources. And you can get very flexible with how you use a service principal. You can make it available to partners, so that service principal can actually allow a third-party tenant, so to speak. If you had a partner that has Office 365, they could actually leverage an application you have and use the authentication through that service principal to access that application in your tenant. So you have some flexibility here, but we're not going to use legacy authentication. So to help better explain what I mean by all this service principal stuff, let me dive into how we configure it. Now, again, you could use Azure Automate, and it would automate the creation of this service principal. But what if you're not going to have access to Azure Automate? What if you need to still run a script on premise? And you need it to use something that's not legacy authentication. Well, we can manually create a service principal here. And to do that, it's called an app registration in Azure. So when I create an app registration, I'm actually just creating a service principal. So I'm going to go to my app registrations in Azure AD, create a new registration. I'm just going to call this CSP demo service principal. Now you can see here I have the ability to make this accessible to other tenants as well, but if I wanted to lock it down so it can only be used in my tenant, that's the default setting. I'm going to go ahead and click register. And what gets created is this app registration object, but what's important is this client ID, because that is unique to this app registration or this service principal. So now I have a service principal. What can I do with it? Well, let's say, again, I want to do a script that runs on premise. So let me open up PowerShell here. And let's say I wanted to do something as simple as connect to Azure AD. I just ran connect to Azure AD. I'm going to get the modern auth prompt, right? So this doesn't do a whole lot of good if I'm trying to script this process. So how can I connect PowerShell now using my service principal? Well, I can do that by actually passing it my service principal app ID, the client ID, and my tenant ID, which is unique to my tenant. Now you might think, well, how is this actually performing authentication? And it's not at this point. We actually have to create a secure means for this service principal to authenticate. Right now, it's just like having a username. You can't get anywhere with just a username. We have to create a way that we can authenticate. Now there's two ways we can do that. You can see over here on the manage blade, there are certificates and secrets. So if I create a client secret, that's pretty much not much more than just a password. So temp secret, and I can say it's only valid for a year, valid for 2 years, or it's valid indefinitely. But when I create this, you'll see that I get this value. That's really just a string. Now, this is only displayed right now. Once I go away from this page, the secret gets masked and I can never see it again, even though I'm an administrator and I created this service principal. But using a client secret, again, is just like a password. So yeah, if I look back at my overview here, I need the application ID or the client ID. That's a pretty complex string, probably not very guessable by anybody, but it's just a string nonetheless. Same thing with my tenant ID. That's just a string, even though it's not very easily deciphered, it's just a string. So combining these two doesn't really provide me a whole lot more security. And if I just add a third string as my client secret, well, hey, that didn't obfuscate that. I think that's changed. Normally, I think that goes away. If I add this third string in here, again, those are just 3 string values that don't really make a lot difference than legacy authentication, right? What I want to look at is using a certificate, because what happens with certificate authentication, now I need to provide something that is stored on my machine or for my user account. I can provide an app ID and my tenant ID, but now I have to provide a certificate that's trusted, that's been issued by some trusted system. So for the demo here, I'm actually just going to create a self-signed cert, but we can do this using a third-party CA or an enterprise CA as well. And I'm not going to type it in. I saved the command here so I didn't have to make spelling errors during the demo. But let me walk you through this. This is a PowerShell command that will create a self-signed cert on my machine. I'm storing it in a variable, so I could leverage the certificate in PowerShell if I needed to. But what this command is doing is pretty much saying, create a new self-signed certificate with the subject name of CSP demo and store it in my personal user store. And then the certificate is exportable. So when I run this command, if it'll run, come on, here we go. And I'll open up my certificate store for my user, not my machine context, but my user context. I now have this CSP demo self-signed certificate. Now, to make this usable in Azure, I have to export it. Now, I don't need to export the private key because that's what validates I am who I say I am. So I don't want the private key to be floating out there. I just need the public key available because that's what Azure is going to need to trust. So I'll export this to my desktop and just call it CSP cert. Great. Now I've exported it. So now in Azure, I can come in here and say, upload my certificate. And I'm just going to go grab that, that CSP cert. And what this is going to do is going to say, hey, what's the thumbprint of that certificate, right? I've got a validity date for the cert. I know the thumbprint, but I didn't upload my public key. So when I use this certificate to authenticate, I have to provide my private cert to, or I have to present, not present my private key, but I have to present the cert to Azure. Just providing it this thumbprint doesn't say, hey, you can use this thumbprint value as a way to authenticate. I actually have to provide that certificate. So now let me go back to PowerShell, and I want to connect to Azure AD. What I want to do is provide it my tenant ID. And if my copy and paste here will work, grab my directory or tenant ID, paste that in here. I need the application ID because this is pretty much going to tell it, hey, this is the service principal I'm using for authentication. Of course, I ran into problems with this where it didn't want to copy before, and I don't know why. So give me 1 second. I actually have to copy it off the page into Notepad and then from Notepad into PowerShell. I'm not sure why. Probably just my system being buggy. And of course, that's not going to work right now either. There we go. All right, so there's my app ID, but now I can pass it the certificate thumbprint. So if I pass it this thumbprint, again, I'm not just passing it a string that I can present. Not anybody can run this this command. Of course, I'm running into a paste error. Sorry, give me 1 second while I get this to work out. Come on. There we go. So now I can go ahead and pass it that thumbprint, and now I'm connected to Azure AD using that service principal and certificate-based authentication. So because I have that cert on my machine and I can present it, I'm able to authenticate. If I didn't have this certificate on my machine, I wouldn't be able to authenticate here, even though I pass it the thumbprint value. So that's where I'm improving my overall security, because now I'm moving away from just a username, password, and maybe a secret, essentially. I'm creating something that I have to have physically on my machine to be able to authenticate. But this service principal doesn't have any rights. If I do get Azure AD user, you'll notice here I get an error. Just because I authenticated doesn't mean I have rights to do anything in my tenant. My service principal doesn't have any rights. So this is where you can get very granular in configuring what this service principal can be used for, because you probably don't want a service principal to be doing everything and anything in your tenant. You want to assign it specific capabilities, and you can do that through the roles. Now, you notice here it says preview, and the main glitch here is if I wanted to add this service principal, for simplicity, you probably shouldn't do this, but I'm going to add it to global administrator. I don't have the ability to assign it here. I actually have to go back into Azure AD, my roles and administrators, and then look for my global. And now I can go ahead and assign it. And I think that's just kind of a glitch as they work out the preview capability there in the portal. But if I go ahead and assign my service principal, and all I have to do here is search for that service principal. So it shows up just like a user or a group would in Azure AD. But now I can select my service principal, assign it to my global administrator role, and I'll talk about this process here. This might look different than what you may see in Azure AD. I'll go into that in a few minutes here. Now I'm assigning it to my global admins role. You can see here now, service principal, it's not a user, it's detected as a service principal, and it now has global admin group membership. Now, if I come back here, I can do a disconnect. I'll disconnect my session. I will reconnect to reestablish a new session. When I run this command to get Azure AD user, it's still going to fail. And the reason for that is, and I don't have a great explanation, but it takes a little while for that role membership to change or to propagate out for a service principal. Whereas if I was a standard user, I would have been successful right here in doing a get Azure AD user. I would have gotten results of all the Azure AD users in my tenant. But for some reason, when you assign that role member assignment to a service principal, it does take a little while. So I can come back here and show you it does go through eventually, but instead of waiting for that, I'm going to get back to our content here so we can continue forward. So that's how we can get away from legacy authentication. How else can we start closing the door on our tax service? And one thing that comes up a lot is risk. Risk, does it help? We've talked to clients to where they want to implement risk-based conditional access, but does it really provide that much value? And it really depends. It depends on how you're using conditional access and your baseline security posture, what you're enforcing from a general perspective for conditional access. And to understand that, we need to understand what user risk versus sign-in risk is. And to do that, I'm actually going to just jump right back into my demo here. And risk detection is part of Azure AD P2. So it does require a little bit of an elevated license. It is included in the EMS E5 as well. But where we see risk is if we look at Azure AD identity protection. You'll see two options here: user risk policy and sign-in policy. Think of it this way: a sign-in risk evaluation is applied every time I sign in. It doesn't matter if it's my 10th time signing in. It doesn't matter if I'm jumping from Exchange Online to SharePoint Online. Every time my account signs in, I'm evaluated for risk, and that is my sign-in risk. All of the different sign-in attempts, all the different signals that have evaluated a risk score for all of my sign-ins over time builds up to my user risk score. So the more moderate or medium sign-in events that I have, medium risk sign-in events that I have, is going to build into my user risk score, which may up itself to high because I've got 20 medium risk events, sign-in events that may say, hey, you know what? You've had enough medium risky sign-ins. We're going to bump your user sign-in score to high, even though I've never had a high sign-in event. But that's the layered approach. So we can define a sign-in risk policy, which pretty much says when I sign in, if my risk is medium and above, what do I want to do? My options here are really to block or allow, and if I allow, require multi-factor authentication. So if we think about this, going back to what I just said on you should be applying multi-factor for every user under every condition, does this really provide value? Because you're already requiring the use of multi-factor authentication regardless of risk, right? So does defining the risk policy here really have value? Well, you probably should still define it if you have Azure ADP2 because it's your blanket policy, right? Let's say someone inadvertently makes a change to your conditional access policy. This is your backup. But again, going to, does it provide value? Well, that's something you're going to have to evaluate on your own. Now, when we look at user risk, though, I would suggest if you define sign-in risk as medium and above, don't define the user risk as medium and above because you're going to hit the same scenario essentially as your sign-in risk. And that's because if I've got a medium sign-in event, it's going to bump my user risk up to medium. If I have a high risk sign-in event, that's going to bump up my user risk score to high. So I really shouldn't encounter scenarios to where my sign-in risk is ever lower than my user risk. My user risk score should be bumped up to match at least my highest sign-in risk event. So if I go ahead and say, select this as high user risk, that gives me a little bit of a differentiation between my sign-in risk policy, right? This will only trigger when I'm high. But what can I do? Well, here my actions are allow and block, but you notice this isn't require MFA, it's require a password change. And the reason I do that, or I would suggest you do this approach with a high user risk, is this is pretty much known compromised credentials for most cases. Now you can have a high user risk score. When you have 20 medium and 100 low risk, that might bump you up to high risk from a user perspective. But if I have a single sign-in high risk, that is typically because I have compromised credentials. Microsoft has detected out there that some dark web or some malicious actor site is published a account dictionary that has my credentials in it. So I'm compromised and I should change my password anyways. So that's why I would suggest you use allow access but require password change. This does require you to use Azure self-service password reset. Otherwise, the users don't have a means to change their password and they're locked out. So that's the risk policies. If we look at conditional access though, how can I use risk? And I'm just going to grab my existing policy here, but it's one of my conditions. So when you have user risk available to you because you have Azure ADP2, I can say, you know what, my user risk is high, medium, low. My sign-in risk is high, medium, low. But again, if I have my risk policies assigned, are there going to be situations to where that risk policy, which is global, doesn't apply to a scenario that I would be assigning risk from a conditional access perspective? I'm not going to have a conditional access policy that says, you know what, if my sign-in risk is medium, require MFA, because I'm already doing that from my risk policy, right? What you may encounter, I guess, is maybe you want to also bump this up to say, you know what, if your sign-in risk is medium, also require a trusted device or a domain joined device, right? I can see a use case there to where you're starting to use controls outside of the risk policy, which is really device trust. And Christian will be doing a whole presentation on device trust here next month for our webinar series. But that's really the only use case I can think of where risk detection would really help from a conditional access perspective. Otherwise, my recommendation to you is to keep your conditional access as simple as possible, mostly because that keeps you from running into a lot of administrative overhead and challenges from that front. So any questions so far before I continue on? I know I've got about 15 minutes left, so I've got a little bit more I want to get through. Any questions?
Hey, Chris, you might want to touch on the difference between sign-in risk and user risk. Kind of on the combination of user and activity and service versus just the user itself.
Yeah, so with sign-in risk, and that's evaluated at every user sign-in event, but there is learning going on in the background. There's profiling that occurs. So Microsoft will detect, hey, this is unusual behavior because this person is signing in from a different location than where they typically sign in from. They're coming from a device they typically don't use. They're accessing a service they normally don't access. That could bump up your sign-in risk, right? Because it's unusual activity based on the profile established by Azure. That helps build into your user risk score, right? So the more medium risk events that you have may bump you up to a user high risk. So the user risk is a compilation of all of those different individual sign-in risk events to say what's the overall user risk level. But I might have a single medium high sign-in risk event because I'm using a brand new device. That doesn't necessarily mean my user count is at medium risk. It just means, hey, we detected one sign-in that was a little bit unusual, but you know what? Everything else seems to be okay. We're not going to throw any red flags. All right. Next thing I want to talk about is reducing your admin access. So Microsoft best practices will say, hey, have at least 5 global or more than 2 global administrators, but less than 5. In most cases, you have more than 5 people that need global admin access, but why have them permanently established with that heightened level of permissions? Why does an Exchange admin or a user that has occasional administrative responsibilities need to maintain global admin rights at all time? This is where privileged identity management comes into play. And let me demo that out so you can see what that looks like firsthand. So this is, again, another P2 capability, but it's a very powerful capability as well. So when I provisioned a new role assignment to my global admins, that may have looked a little bit different than some of you may have seen in your tenants. And that's because privileged identity management is activated in my demo tenant here. So when I look at global admin again, let me pull that back up. You'll notice here when I did the assignments, let me just grab, I'll pick on Ken. If I wanted to make Ken a global admin, and by the way, that is not Ken's picture, that's just whatever was in my demo tenant. We have the assignment type here. There's eligible and there's active. Now, by default, without Azure AD P2, it's active because it's just permanently assigned in as a global admin. Now, if I wanted to say, you know what, Ken can elevate himself as a global admin. He can do that now because I've made this eligible, but his standard mode of operation is a standard user. He doesn't have global admin rights. Now I can also put a time box around this to say, you know what, he's only eligible to elevate his account to global admin during this specific date range. So I can control that. So I'm going to say permanently eligible. Click activate here. So now you'll see Ken's now an eligible assignment. So if I look at, well, what's the workflow around that elevation? When Ken needs to use global admin, what happens? Well, he can just go to portal.azure.com, go to privileged identity management, and he'll get this view here where it says my roles. When he clicks on my roles, he'll see global administrator now listed here under an eligible assignment. And there's going to be an action link here to click activate. And I'll go ahead and add everyone into this after the demo. So if you wanted to log in and see how it looks firsthand, you can do that. But right now, as it stands, he can self-elevate and there's no workflow, nothing around that to say, hey, you need approval. He's just going to be elevated for global admin privileges because he requested it. But I can control that. So if I go back here to the Azure AD roles, and I know I'm clicking around fast, but I want to get through. I've got some other things I still want to show you. If I look at global admin now, under the settings, here's all the elevation settings I have available. So right now, he can elevate his account, but for a maximum of 8 hours. After 8 hours, he immediately gets pulled out of that global admin's assignment, and he's back to a standard user. Does he have to provide justification? So maybe you don't have workflow for approvals around this, and that's fine. But this at least gives you an auditable trail of who's been elevated and for why. So if you have your audit logs being exported to a SIM, or if you just need to query back 90 days to see why someone's elevated their account up to a global admin or any other privilege role, you can do that because we're requiring justification. We can even integrate into any kind of ticketing so that we can create a ticket event or require MFA. So if Ken goes to elevate his account, he has to provide MFA to do that. So we're protecting his account right then and there to say, hey, you can't just go ahead and elevate yourself, even though it's self-elevation, without providing MFA. So we know that your standard account is at least protected via MFA. And then if I wanted to do approvals, I could assign people here into this approvers group that they have to go ahead and approve Ken's request to elevate before he's actually elevated into that group, into that global admins. So this is kind of giving us that just-in-time admin access. But if we look at from a security posture, we really should be taking that approach because the standard mode of operation, if Ken's account becomes compromised, it doesn't necessarily mean he's immediately, our whole tenant's compromised because they have global admin rights. His standard mode of operation is standard user. So his compromised account doesn't have that benefit. Let's say that bad actor tries to go and elevate Ken's account. Well, he's now got to provide MFA, and that's not something you can easily fake. So Ken's going to get a pop-up in his Microsoft Authenticator app or a text message on his phone. And that's going to set a red flag, say, hey, why is someone trying to perform MFA? Because I didn't do anything that required MFA. And that bad actor won't be able to access elevate to global admin. So definitely a good impact onto your overall security posture by reducing your global admin exposure. I am going to breeze over this because, as I mentioned, Christian will have a whole session on it next month on protecting your devices and establishing trust with your devices. So one, I don't want to steal any of his thunder, but also in the mindset of time, I want to jump into the next thing. But real brief overview here from a attack surface reduction, leveraging device trust with conditional access will significantly impact your security posture because now you're going to be able to make sure the devices users are connecting to the service are trusted. They're in tune and roll. They're trusted because they're domain joined. Or we can look at things like mobile application management to where, okay, maybe it's BYOD and we don't need to trust the device, but we're going to still protect our company data. and I'll let Christian dive into that next month. But what I want to touch on here before we run out of time, controlling the session. So let's say that you can't control the user's device. There's still a need out there, even though it's not great, good practice at all. But maybe someone has to access a hotel kiosk or an airport kiosk or use an untrusted device to do something business critical. You don't want to stop them from being able to do their jobs, but at the same time, if we're looking at reducing the attack surface, we also don't want to just allow any untrusted device or any unknown device access in the environment. And you might be protecting the user account with multi-factor authentication. That's great. But what else can we do to make sure that we're protected? And that's really looking at controlling this session. And specifically, this is looking at Microsoft Cloud App Security. It's how we can dynamically apply controls within the user session. And a good use case for this is, hey, maybe we want to allow the use of a hotel kiosk, but you know what? We're not going to allow any data extraction. And an easy way to do that is just block file downloads. So a user can't connect Outlook, they can't use any thick clients on the desktop, they have to use a web browser, and now we're going to prevent the use of file downloads. So if I go back to the demo here, I'm going to jump into my standard user here, which is this Megan. You can see here I've logged into SharePoint, and I could easily come in here to SharePoint and say, you know what, download this file. Right now, you can see I can download Brandon Elements PowerPoint deck, and now I have a local copy of that on my desktop. But if I want to prevent that, I can easily do that. And I don't need to dive too deep into MCAS. I don't even need to go to the MCAS portal here, in all honesty. Conditional access is going to be our drive-in element here. And I'm going to create a quick new policy. I'm going to go quick on this because we only have a few minutes left. But I'm going to apply this to, I'm just going to apply this to everyone. And I'm going to apply it to SharePoint. Come on. You don't necessarily want to apply this across the board because it can interfere with the admin portal a little bit if you don't think about it correctly. I'm not going to look at conditions for grant. I am going to grant access, not check any of these boxes unless I really wanted to make sure MFA and everything is required. But what I'm going to look at is a session control. And the main item here is use conditional access app control. And what that really means is pass it off to MCAS. We have a baked in option here for block downloads. And what the nice thing about this is this is a very common use case. I don't have to create any custom policy in MCAS. I'm doing it right here with a drop down from conditional access. So now when I turn this policy on and create it, I'll have to go back to my Megan session here. Where is it? Here we go. I am going to sign out. All right, and I'm going to go back to portal.office.com. Megan B, give it that terrible password. You'll notice I go right into the portal and I'm going directly to office.com. I wasn't proxied, but if I go to SharePoint now, you can see that redirection here. Now I have accesscontrol.cas.ms. That is MCAS proxy in my connection because now I'm within that conditional access policy. So I can hide this warning if I wanted to, but this is pretty much going to be the default page that pops up saying, hey, you're being monitored by MCAS. Continue to SharePoint. I go ahead and look at SharePoint and I want to pull down a file. Come on, SharePoint. Here we go. For the sales and marketing. And I'm just going to find any document here. Probably should have gone to the pane there. Here we go. And try to click download. So when I click this, notice the file that I'm being shown here is a blocked with the date.txt, and that's not the PowerPoint presentation. That's just going to be a text file that gets downloaded that says, hey, you can't do that. And even the website is now telling me, hey, download blocked. So this is a great use case for if you do have people who travel and do have to use untrusted devices here and there, or maybe you want to allow your employees to use their home computers, which aren't trusted. You can easily scope this now to use something like MCAS to prevent your data from being extracted out of your tenant. They can do all their work in the portal, but they can't pull any files down. They can't save anything locally. So all your data is still protected. And you could go even further with that if you wanted to with MCAS to say, hey, we're going to apply AIP and rights management and things like that to the data. So even if it is downloaded, it's protected. I know I've got like 1 minute left here, and that actually was going to be my last topic. But luckily, I do have a whole session on protecting your data. But that's your last kind of surface attack reduction item here is protecting the content itself. So if you can't close those doors all the way, you can't protect all those devices, and you need to share data, that doesn't mean that you're still leaving yourself vulnerable. Protect the data. And I will have a session, I think, actually, let me go to my next slide here. That session is our last one, so it is a while in December. But I'll go deep dive into the use of data protection using AIP and Microsoft information protection and what the differences are there. So with that, these are the upcoming sessions in our webinar series for CSP. As I mentioned, Christian will be doing the securing devices and establishing trust next month, and then we'll be going into monitoring and managing access in October. So I hope to see everyone on those. I'll send out reminders. Also, I will send out a follow-up questionnaire for this event, and I would appreciate any feedback. I appreciate the time people take to fill it out, but really, we want to make these as valuable and beneficial to you as possible. So give us some feedback if there's topics you want to hear on specifically, if there's things that you didn't hear about today that you wanted to hear about, let us know, because we're more than willing to put more sessions together to address what are your specific needs as our CSP customers. So with that, I've talked a lot and really fast, but tried to get everything in before the hour. I will turn it over to the questions if there are any. So any questions, feel free to come off mute.